Okay. Well, hello everyone. My name is O'Neil Mbakwe, and today I will be talking about AnyText diffusion and its ability to be a multilingual and visual text-based generation model that allows for image generation and um, image editing with text. So today I will be giving an overview about diffusion-based models, its current challenges, and some examples of diffusion-based models, and how AnyText is there to solve the challenges of diffusion-based models, current diffusion-based models. After that, I will get into the method and structure of AnyText, going into a deep dive of the architecture of AnyText diffusion-based models and how it works. After that, I will show some examples of prompts and images that were generated through AnyText, followed by a live demonstration of using AnyText. Uh, to finish it off, I will give my thoughts about about AnyText, the diffusion-based model, areas for improvement, as well as pros and cons of AnyText. So, with that being said, let's get into it. Overview. So, first of all, what is a diffusion-based model? And a diffusion-based model is a type of generative model that operates by updating a probability distribution over the data space. And the models that are created are used in tasks such as image generation, where the goal is to generate realistic samples from a given data set. So basically, imagine you have a bunch of random dots on a piece of paper, and the dots don't make any sense. They're just random noise. So with these dots, you want to turn them into something cool, like a picture of a car. A diffusion-based model is like having a logic process that gradually transforms these random dots into a car picture. But instead of instantly turning them into a car, it changes them bit by bit, slowly making them look more and more like a car over time. And with diffusion-based models, they have been transformative in industries or sectors like digital art, photography, and we've seen examples of diffusion-based models through commercial use of things like Midjourney or DALL-E. Now, even though there are significant benefits to current diffusion-based models, like its um, its legibility, the generation and accuracy of the things it's able to develop, there are still challenges that are seen in current diffusion-based models, like the ability to solve for blurriness or legibility or uh, multilingual image generations and text generations as well, text editing as well, I mean. And with AnyText, it is here to solve that problem or attempt to. So AnyText is a diffusion-based multilingual visual text generation model that we will get into now. Before I get into the meat and potatoes of what AnyText is, I wanted to show a diagram, or no, I wanted to show some examples. So in this photo, if you look to the left, you'll see text generation, and to the right, you'll see text editing. So in the text generation, how it works is with the prompt. Let's say, for example, the first one to the top left corner, it says an eye sculpture was made with a text, happy and holidays, a DSLR photo. Now, all that is taken and put into the AnyText model. And what spews out is this image that we have here with the inscriptions and the image both adjoined cohesively. Now that's an image, that's the example of the text generation. You see there's multiple, but now we move on to the text editing. Now, AnyText has the capability of having a current image that has text on it and editing the text for it to output something else. So for instance, we have happy birthday, but the section that we want to change is birthday and change it to every day. Giving a prompt, which we will talk about further along this presentation, it spews out the requested update or edit to the text. So it says every day. Now, what's interesting about AnyText is that it can do this in multiple languages through a feature, an OCR feature that doesn't classify the text as text, but classifies it as an image before encoding it into the model. So we'll get into that right now. So boom, AnyText. Yes, it is a large diffusion-based multilingual model trained on, I'm going to butcher it, so I'm just going to spell it out loud, LAION hyphen glyph hyphen 10M. And AnyText, the model is comprised of three parts outside of the neural network UNet. And those three parts are auxiliary latent module, the text embedding module, and the text perceptual loss. So if you look at the top, there's a prompt that says photo of a lush estate with a sign that reads Beverly Hills. Now, this prompt is fed through both the auxiliary latent module and the text embedding module. So I will start with the auxiliary latent module. The purpose of the auxiliary latent module is to encode auxiliary information. And as you can see, we have the glyph, which takes the word. We have the position, which is where you are able to mask where the words are supposed to go. And then you have the masked image, which is generated through the data set based on what the prompt gives. Now, if you look in the masked image, we have two options between an image and then one with just a complete mask on it. That's because the feature of AnyText allows for either text editing or image generation. If you're doing text editing, the only part that is masked is the text space. But if you're doing image generation, then the whole image will be masked. Now, once all these are collected through a glyph block, a position block, and the masked image is fed through an autoencoder, it's then put into a fuse layer. So boom, it goes into the fuse layer, and then it is set up to be processed through the test control net and the UNet. So before I get into the test control net and UNet, I've given the setup of the auxiliary latent module, and now we'll move on to the text embedding module. Now, with the text embedding module, the function is for it to employ OCR model to encode the text and the images. So in the text embedding module, how it works is that it extracts semantic information from caption as well as image. And how it's able to do that is through feeding the prompt through the text embedding module. Number one, it's fed through a tokenizer, and that tokenizer is then put into the embeddings. And this part is actually pretty interesting, I thought, because when it's fed through the tokenizer and kept in the embeddings, it's held into the embeddings while the text or the prompt is also fed through a what we call OCR, which is object characterization. OCR has to do with image identification, characterization. Forgive me if I'm butchering it, but yeah. So once the text is fed through the glyph render, out of it is created an image, which is then fed through the OCR. And once the image is fed through the OCR, it replaces the tokens that are in the image, in the current embeddings to be fed into the text encoder. Now, the interesting thing about this and why it's so important in any text is because this is how it's able to read different languages. So instead of reading different languages as text, it uses the OCR as to identify the features of the image created. If you notice, if you see the words Beverly Hills, there's Beverly on top, Hills on the bottom, and they're both in their separate gray boxes, which shows that they're two separate images. In the text embedding module, all text um, that are in is supposed to be in a single line or in quotations are a separate image, whereas in the auxiliary latent module, all text is created on a singular image. This gives the text embedding module the ability to identify the features of each image to, in a sense, translate what it's saying. Um, so boom, as that's fed into the embeddings and replaces what was currently standing, they're both fed into the text encoder. And once they're fed into the text encoder and set through the text control net and the original UNet that is standing frozen cannot be changed, the text is controlled and the image is then generated. Uh, then we make our way to the text perceptual loss. So after it's encoded and the image is generated, what text perceptual loss does is fine-tunes the image for accuracy. If you can see between this first example, Beverly on the left and Beverly on the right. Beverly on the right looks more prompt. No, not prompt. It looks more fine and clear. That's why it's very important to have this masking ability for any text because it improves the accuracy because now it gives the text perceptual loss an area to focus on to improve. So with all that being said, this is the general architecture of how the AnyText works and how it's able to not only read in one language, but also other languages. So next, we're going to get into some examples of AnyText being used. Okay, boom. First example, the prompt says a photograph of the colorful graffiti art on the wall with the words, "Hi, get ready to party," all in separate quotation marks, depicting or indicating they'll be in different lines. So after that, the user then creates the mask. So you literally just draw it, and we'll get into that when I show you the live demonstration. You just draw it. So one line here, one line here, one line here, one line there. Click run, and it generates the image. Now, something that I really enjoyed about using AnyText is that it gave you multiple options, not just one. So you can select which one that you wanted to use. Another example is it being used in a different language. And I am not even going to try to translate what it says because I'm not going to do that. So I will make inferences on it though. So you'll see that you see in quotation marks right here is the words that are going to be used. And my best bet is that this is saying a photograph that is crayon with a mushroom house and a hill and blue trees, something like that. But then the words you see here are masked for the bottom. What AnyText does is generates the image, then with the masks, it fills in the text. It fills in the image with that text and conforms it to the format of what the actual image is. So this is image generation, and we'll move forward into text editing. So in this example, the prompt says a cake with wonderful, colorful characters that reads every day. So the original image says happy birthday. But after creating a mask over where the edited text is supposed to be placed, the AnyText model erases, well, not erases, I would say it masks over the birthday and replaces it with every day. This one is pretty interesting, but there were some discrepancies that I noticed that we'll get into at the end of the presentation. Another example in a different language. Again, don't know what it says. But if you look at the um, the original the from the edited final one, it's interesting because it's you see the OCR coming to play because in order to identify it, it had to take the features. In order to identify what the image should now read, it had to take the features that were extracted from the OCR and fed into the encoder. So the image that was extracted was this. And now that extracted image is, no, we're here, this. And now the extracted image is right here. There we go. Yes. As well as the first one right here being extracted right here. Yeah. So next, we will get into a live demonstration of this. So I'm going to go ahead and exit out this screen and go to the live demonstration. So we're going to take this off. We started for this purpose. So the prompt says a photo of a blimp that has the words, "I'm a blimp in the afternoon sky with birds." So after creating the text prompt, what I do is draw the mask based on where I want the word. So I'm a blimp. And what's interesting about AnyText is that you can either manually draw the mask or you can have manual rectangles to show where you want the masks to go. Um, for this one, we'll use the manual draw. So boom, let's run this. Yikes. So this is probably due to the prompt that was given and how it was written, uh, which is 100% okay. And it also shows that each time you run it, it'll give you a different generation of image. So let's see what happens if we run it again. Look at that. So this is an image that I really like because it conforms to the blimp and it gives the correct text. And it's pretty accurate and close to what I asked for. So moving on to the text editing. Here's a photo, and the original one says, "I love my mommy." Now, I instructed to say characters written in chalk on the blackboard that says grandma. So because there's only one word that says that is in parentheses, I mean quotation marks, what I'll do is use this mask, which I've already used, and replace it with the word grandma. So let's run that. Boom. Now, let's run this one more time. Slides where we talk about the crons and improvements is going to be great. So we already see some masking discrepancies with the live demo session. So let's try and run another one and see if one of the examples they give is a bit better. Okay, good. So this one originally says a text from the right person can change your whole mood. But this one says a text from the wrong person can change your whole mood. Great. So that was a live demo session of the AnyText based model. So I'll get back into the presentation. What we learned, what worked and what didn't. So one of the things that I noticed and that we have noticed today on this live demo session is the text formatting. Now, in this image, um, the sign was supposed to say two-pack. However, after creating the mask and putting the words in, it gives the word to Tuiae. Uh, I believe it's due to um, a masking, a masking. I don't want to say it's due to masking, and I think the way to improve that is just more fine tuning of the masking to allow for text formatting to conform in the positions where is designated. Another thing that we noticed was facial features, and this has to do with data and do with training, but creating an image that can create facial structures that are accurate. Like in this example, we asked for Brad Pitt in front of a large poster with the words, I am Brad. It says I am Brad, but that does not look like Brad Pitt. So more data training and fine tuning to give more facial features. Now, something else I wanted to point out was in this slide, if you can look closely where you see these toothpicks on the letter H and connected to the cherry versus where it is now in the edited image. It's just standing there, whereas before it was meant to be what was holding the candle in place. It was meant to be what was holding the letter in place. So what I see is, more fine tuning on the masking and developing that to be able to not only write over, but more so blend in with the photo based on where things already are in their position. Overall, the pros was that it was definitely accurate than other diffusion models. Um, it gives multiple variations from prompts, and due to the OCR, it is multilingual and able to emit, generate and edit image of different languages. Cons were the masking effects on textual input and inaccurate depictions of facial features. Okay, well, and that was the presentation for the AnyText diffusion-based model. Is there any questions?